So we're going to continue our discussion on trigonometric graphs, and now we're going to talk about tangent and cotangent and cosecant and secant graphs. So the functions tangent and cotangent have a period of pi. So tangent of x plus pi, that means any number of pi's is going to equal to tangent of x. And then cotangent of x plus pi will be equal to the cotangent of x. The functions cosecant and secant have a period of 2 pi, just like sine and cosine. So they'll be x plus 2 pi's in either case. They're going to be equal to the thing. And we talked about that last time, where if we are at a value and then we go around the circle, we're going to hit that value again. And around the circle, we'll hit the value again and again. Either way we go. So we first sketch the graph of tangent. Since it has a period of pi, we're only going to sketch the graph on any interval length of pi, and then it'll repeat the pattern to the left and to the right. We sketch the graph on the interval of negative pi over 2 to pi over 2, since tangent, pi over 2, and negative pi over 2 aren't defined. So let's talk about that. So tangent, remember, is sine over cosine. And anytime we divide by 0, it's going to be undefined. So where is our functions undefined? Well, cosine is equal to 0 at pi over 2. And if we came down here to negative pi over 2, because 3 pi over 2 would be the same, but we're going this way to pi over 2. So that's where our cosine functions are 0, which makes tangent undefined at those two values. So that's where we're going to, the period of tangent would then be between pi over 2 and negative pi over 2 down here. It's going to be in this area here because of the fact that it will be undefined at those points. So we have to be careful in sketching the graph at points near pi over 2 and negative pi over 2, because as the x will gets near those, the values, if it gets through the values that are less than that, the values of tangent x become very large. We're going to notice this as it gets closer to that. Cosine approaches 0, so it gets really small, and sine approaches 1, so it gets bigger. So that sine over cosine, something that's close to 1 divided by something that's close to 0, is going to get large. And we can see this in a table of those values. So here is a table to look at the values of tangent. So we start out with 0, 0, and then we end up with going to 0.58. It's not too bad. Let me see that, just it's a little blurry there. But you can see that exponentially it just keeps growing bigger and bigger and bigger. So, and pi over 2, that's half a pi. Well, pi is 3.14, so we're getting closer to these values. Because half a pi is going to be, half of that, 3.14. So we're going to be at they're going clear up to 1.57. It's getting up to 10,000, so it's going to go up really fast. So by choosing x close enough to pi over 2 through the values less than pi over 2, we can make the value of tan x larger than any given positive number. And we express this by writing that as the tangent of x is approaching infinity as x is approaching pi over 2 from the left. And here we have tangent of x approaching negative infinity as x is approaching the value of negative pi over 2 from the right. You'll see more of that kind of stuff in calculus. So the graph of y is equal to tangent x approaches the vertical lines of x equals pi over 2 and x equals to negative pi over 2. And those are called vertical asymptotes. We learned about those in college algebra. So here we've got our two vertical asymptotes, and this will be what our graph of tangent will look like. This is one period of tangent, and this is what cotangent will be. Now cotangent is between 0 and pi. Now let's talk about that. Cotangent is cosine over sine, and sine is 0 at 0, and then over here at pi. So those are where the asymptotes will land for cotangent, because sine is in the bottom, and wherever sine is undefined at 0 and pi and 2 pi and 3 pi and so forth. So that's where those asymptotes will be for there. So if we look at the complete graphs, here is what a tangent graph where it repeats from on the left and the right, and the cotangent does as well. And then we will also do some transformations where we multiply. If we multiply by 2, so things get stretched up. And if we have a negative, it will flip it. So this looks like a cotangent graph, but you can tell by the values of our period there that it's still a tangent graph, but it looks very similar to that. Now for cosecant and for secant, we're going to take the reciprocals of the y-coordinates of the points. So where sine is equal to 0, it's undefined. So at x equals 0 and x equals pi are vertical asymptotes. And for secant, we take where y is equal to, we're looking at the coordinates of the points where the graph is y equals cosine of x, and so we're still flipping those. All right, so where cosine is equal to 0, the secant x is undefined. So x equals pi over 2 plus n pi for any integer are going to become those vertical asymptotes. So here is cosecant. Remember, cosecant is the reciprocal function of our sine graph. And so it's where cosine is at 0 is where we'll have our issues. It's where sine will have our issues, because wherever sine is equal to 0, I was in my cotangent thought there, or tangent. So where it's the reciprocal of sine, so wherever sine is equal to 0, which is at 0, pi, and 2 pi. So we will have vertical asymptotes. This graph kind of shows you what the sine curve would be. So you can see that the cosecant comes up and touches that. We won't draw it with a sine, it just helps you see it. So if we're looking at a regular cosecant, we're down here. This again would be where, now this one is coming up like this. It just depends on where here we have the graph on a little bit different. This graph here is this part up here. So you would see that it would kind of come along like this. And then here we have our secant, which is the reciprocal of cosine. So if we had our cosine graph here, this is what our secant graph will come up and touch those parts. And then this would be what it would also look like. So here you're seeing one period of it, so you see half of that, but if you had multiples of it, you would see the whole thing occurring. This is one period of each of those, and this is what it would look like if you stretch it out. So that just gives you an idea. We also have similar things here with our amplitude and our period. So y is equal to a times the tangent of k times x, and y is equal to a times the cotangent of kx. Of course, k still can't be 0, and it has to be greater than 0. This will have a period of pi over k instead of 2 pi over k, because our period for tangent and cotangent is pi. So your complete periods will be from 0 to pi over k. All right, let's go do some graphs now that we have a little bit of an understanding of what's going on with our tangent and our cotangent graphs. So the first one we're going to look at will be y is equal to 2 times the tangent of x. We saw a brief look at what the graph looks like, but we're actually going to graph it. All right, so these graphs are a little bit different on drawing. So first we've got to go draw our line. It's not going to be where we just go the lengthwise, because this is tangent and cotangent. So I'm going to draw this, we know that on the outskirts here we have pi over 2, or sorry, negative pi over 2, and we have pi over 2. And these will be asymptotes, vertical asymptotes. They've got arrows on either end. I'm going to draw my asymptotes first. And I know that basically what happens with my tangent graph. So I'm going to draw a tangent graph and then we'll multiply it up. All right, so we've got this one and this one. Again, we're going to do those hash marks for convenience. And we've got 1 on either side. So here's a 1, negative 1. We will end up going, because we're going to multiply by 2. And so we'll end up here at negative 2. So on my regular tangent graph, I would be hitting this point and this point, and I will go through the 0. So it's going to be an at the asymptote, it's going to get larger and larger. So you're just going to kind of come in and curve, and then curve up, and try to curve. It's hard because I'm trying to also do dashed lines. Now so that gives us an idea kind of what it would be. It needs to kind of curve a little this way and curve a little this way. I will try to do a little bit better job of it. And then this one with the 2, so now we'll still be here, but we'll be up at the 2. And then here we'll be down at the negative 2. So it's still going to kind of graph. So we're coming up to that asymptote and we're getting bigger. So we're going to kind of come through here. It's going to kind of come up and curve. And kind of, oops, I curved too much. Sorry about that. And we're going to kind of curve. Not a perfect graph, but we'll get better at it. Again, if you're sketching it, you're just sketching. And I'm not using pencil, so I can't erase and try again. All right, let's try a y is equal to the negative of tangent x graph. So, yeah, I curved a little too much here. I should have curved up a little bit more to catch it. And part of it is the spacing. I've not made maybe it a more representation of the graph. So let's see if we can do the negative of tangent x better. Alrighty, so we've got a graph here. And we're going to be at our negative pi over 2. We'll do our hash mark. And here's pi over 2. And we're just dealing with 1 because we only have that negative value. So it'll be 1 and negative 1 because it'll be flipped around. So negative 1 and 1. Here will be our asymptotes. So our original graph will hit at this point, and this point. So let's see if I can kind of curve this a little bit better this time. All right, so that's a little bit better. So for the negative of tangent, it will hit at those points. So we're going to kind of come in from here and do kind of a curve this way. That's much better. Looks way better than that one. Sorry about that. I am not an artist. I've told you guys that before. All right, let's go look at y is equal to tangent of 2x. So with that 2, that changes our interval. That's all it's really going to do a whole lot with. So remember, it changes the period. So our period, again, is pi over k, right? Or, sorry, yeah, pi over 2k. Let's go back in. We talked about the period. So our period is pi over 2. Oh, here it is. Yeah, pi over k. Here it is, pi over k. And so we are looking at the period is actually negative pi over 2 to pi over 2. So if we're doing that k, so let's look at the interval. So we're going to, and these don't have brackets because it'll be undefined at those spots. So that's where these won't have brackets, they'll have parentheses. So we're at negative pi over 2, and then it's divided by k, so we can say that it's negative pi over 2k to pi over 2k. Our k is going to be 2, so that will get us to negative pi over 2 times 2 to pi over 2 times 2, which will then get us to negative pi over 4 to pi over 4. So that's where our interval will land, and that's something that we need to know in order to draw our graph out. All right. So this will now be negative pi over 4 to pi over 4, still our asymptotes. And our points, we've got to have our 1 and our negative 1, and then our halfways there. All right, so we are landing about here, here, and here. So we're going to come in and do that. All right, so that would be that graph. Now let's look at y is equal to the tangent of 2 times x minus pi over 4. All right, so this is basically the graph we just had of 2x, but now we're going to shift it pi over 4. So we can look at this graph. It's going to shift to the right, so it's going to be scooched over pi over 4 because we're shifting it. So now our interval we knew was negative pi over 4, so for the interval, we are adding our b. So we already knew that it was at negative pi over 4, and we're going to add our pi over 4 of our b, and then pi over 4 plus pi over 4. So we're taking this interval that we found for the actual graph of the tangent of 2x, and now we're adding the shift in there. So that'll get us from 0, and that'll end up being 2 pi over 4, which will be pi over 2. And understanding those intervals, so I purposely chose so you can see from here it's just going to get shifted over. All right, so this time our graph will look a little bit different because this is where our 0 is. It's still going to be where the asymptote, we could kind of do the asymptote on either side so that we understand there's an asymptote happening there. And then we'll have pi over 2 will be our asymptote here, halfway between, and then we also need the halfways between. And we'll get a 1 and a negative 1. All right, and again, these are the endpoints or the important parts that you need. You can figure out the rest. I mean, this would be pi over 4, but it's not essential. So here, we're going to land about here, and we're going to land about there. So we will kind of come up and grab it. And we'll extend it that way a little bit. And there is that graph. So we're just sketching. We're not looking for super detailed graphs. Just something that looks like the graph. Make sure you get your intervals correct, but you don't need a gazillion points on them because that can drive you a little crazy trying to do all these graphs. It'll also get very tedious and time consuming in your homework. All right, our next one we're going to look at will be y is equal to 2 times the cotangent of 3x minus pi over 4. Now, we're going to need to factor out the 3, because remember, it has to be with just an x. So I need this pi over 4 to get a value where I can factor out a 3. So I need a 3 pi on the top, so what I do to the top, I do to the bottom. So I'm going to rewrite this as 2 times the cotangent of 3x minus 3 pi over 12. 3 over 12 is the same thing as pi over 4, but now I can factor out a 3. So y is equal to 2 times the cotangent of 3 times x minus pi over 12. So I could factor out the 3. So now I can find my period. My period would be equal to pi over k. Our k is 3, so it'll be pi over 3. And it's going to shift pi over 12 to the right. So if I know that my period is pi over 3, this one cotangent starts at 0. So I know it's 0 to pi over 3. But because of the shift, I'll have 0 plus pi over 12, and then pi over 3 plus pi over 12. Well, the first part is easy because it will just be pi over 12. On this part, we got to get a common denominator. So pi over 3, I can change to 4 pi over 12 by multiplying 3 times 4 gets you to 12, and 1 times 4 gets you to the 4, plus pi over 12. So that'll get me pi over 12 to 5 pi over 12. So that'll be my interval. All right, let's go graph this. So I know I need to start at pi over 12, and I'm going to end at 5 pi over 12, and both of those will be asymptotes. And then I'm going to be a halfway in between, which we could understand is 3 pi over 12, but it's not essential that I put all of that in there. And then I need a halfway and a halfway. And then I know that we're being our amplitude is going to be 2 there. Not our amplitude, it's a different graph. We're being multiplied by 2. So normally we would be at 1 and negative 1, but we're going to be at 2 and negative 2. So on these, I'm still going to cross at this point, but here I will be up to here, and here I will be down to there. So my graph will come in like this, and cross through, and cross, and keep on going. All right, so again, doing the endpoints makes it a little bit easier than trying to do all the denominators and that. All right, let's go look at another one. Let's go look at a cosecant graph. So if we do y is equal to 1/2 cosecant of 2x. So again, we've got to find the period. The period for cosecant is going to be 2 pi over k. Our k happens to be 2, so 2 pi over 2 will get us a period of pi. So it's going to go from 0 to pi. And we have to figure out where those asymptotes occur, because we do have two asymptotes. So when we're looking at where this is cosecant, so it goes with sine. So we're going to have asymptotes. And the asymptotes will occur at x is equal to 0 over k, at pi over k, and at 2 pi over k, because that's where our sign values are equal to 0. So that means they're going to be at x equal to 0, x equal to pi over 2, and x equal to pi, because our k value is 2, so it's going to occur at those spots. Alrighty, let's go draw this graph. So we're going to have our period is from 0 to pi. So halfway between would be pi over 2. Both of those will be asymptotes. And then we're at 1/2. So we'll have 1, so there'll be 1/2. This would be -1, so there we're at -1/2. And so our graph is going to, let me draw a little, just an idea of kind of the middle part. So we're going to be right here, and we're going to be like right there, just so I get an idea of where the graph will come down to. So it's going to come down this way and then hit and curve back up. And here it's going to come up and curve and come back this way. So, whoops. So there's a sketch of that one. And again, we're looking for sketches, not exact graphing. All right, next one. And you can graph all this with a graphing calculator, but to me it's important that you learn where these graphs are lying and learning the basics of the graph so that you can sketch it. You don't need a calculator to show you how to graph it. You should know and understand it. All right, so the next one we're looking at is y is equal to 3 times secant 1/2 x. So let's go find our period first. So the period for secant will be 2 pi over k. Our k is 1/2. So 2 pi divided by 1/2. Again, we don't divide by fractions, we multiply by reciprocals. So that becomes 2 pi times 2, which will be 4 pi. So our interval will be from 0 to 4 pi. And then those asymptotes are going to be where cosine 1/2 is equal to 0. So where that cosine of 1/2 of x equals 0. So that'll be where x is equal to, where does cosine equal 0? Well, that is at pi over 2. And it'll be at 3 pi over 2. But we have to divide by our k again, because that k changes where those values land. So here we'll have pi over 2 divided by 1/2. Don't divide by fractions, multiply by the reciprocal, and we'll end up with pi. And x equals 3 pi over 2 divided by 1/2. Multiplying by the reciprocal, we will end up with 3 pi. So we're going to have an asymptote here and an asymptote at 3 pi. All right, so let's go draw our graph. So we are looking at from 0 to 4 pi. That'll be at 2 pi. We have a asymptote at pi and 3 pi. So I'm just going to do hash marks there. And do my asymptotes. And then our, we're being multiplied by 3. So we'll have a 1, a 2, and a 3. and a -1, a -2, and a -3. All right, so for this graph, we are going to come in from this point and go up this way. And then this part of the graph will come in at this point and come up and do this. And then this point here because we've got to stop at the 4 pi, will curve up like this. And there you go. So that's graphing all of these types of graphs. And hopefully this made complete sense. And that you can understand how to do it. And again, marking the significant points and letting the other ones go.